Imagine it's a hot day and you're thirsty. What's your go-to drink? Probably a soft drink or a cold sweet drink, right? But did you know that soft drink consumption can lead to obesity and diabetes? What if there's a healthier and natural alternative, one that not only refreshing but also good for your gut? Let us present to you ginger soda. In Thailand's hot climate, consumers often choose cold beverage to cool down and refresh themselves. Carbonated drinks are a popular choice. Even though soft drinks are undeniably delicious, consuming them in excess can have negative health effects, such as diabetes and obesity due to their high sugar content. That's why choosing a healthier alternative is essential. So what are we trying to find out? Here are our main objectives. First is to study the effects of different temperatures and environmental conditions on the fermentation process of probiotic ginger soda. Second is to compare the production of carbon dioxide in probiotic ginger soda under different conditions. And third is to compare the sugar content in probiotic ginger soda under different conditions. Before we started our experiment, we made a prediction. We predict that if the temperature affects the fermentation, then the bottles stored at higher temperature will produce more carbon dioxide than those at lower temperatures. At the same time, the higher the temperature, the less sugar will remain in the drink. Let's talk about the key factors in our experiment, our variables. First, our independent variables. In this case, the environmental condition in which the probiotic ginger soda is stored. Next is our dependent variable, which is the amount of carbon dioxide produced in the probiotic ginger soda under different conditions. And lastly, we have our controlled variables. These are the things we kept the same to ensure a fair test. We control the fermentation duration, the bottle size, and the ingredient ratio. To test our prediction, here is step-by-step experiment to observe how temperature affects the fermentation of probiotic ginger soda. Firstly, prepare the ginger bug. By mixing the ingredients above in a glass jar, stir until the sugar is fully dissolved. Cover the jar with cheesecloth and let it sit for 24 hours. After 24 hours, repeat the first step daily for approximately 1 week or until bubbles form in the mixture. Then we prepare the ginger juice by mixing the ingredients above. Heat it for 5 to 8 minutes and let it cool to room temperature, then strain it finely. And lastly, we mix the ginger bug with the ginger juice by mixing 90 grams of filtered ginger bug liquid, 90 grams of lemon juice, and the ginger juice. Pour the mixture into pressure-safe swing top bottle, 2 inches of space at the top. Now, we store each bottle in 3 different environmental conditions as follows. The first bottle stored at temperature of 29 to 31 degrees Celsius. Bottle 2 stored in a place exposed to sunlight in a room temperature of 28 degrees Celsius. And stored the last bottle in a dark environment in a room temperature of 26 to 27 degrees Celsius. Now let's move on to our result and conclusion. From our experiments, we found that the temperature plays a major role in carbon dioxide production during fermentation. First, at higher temperature, the probiotic ginger soda produced the most carbon dioxide. Second, when exposed to sunlight, carbon dioxide was produced but in smaller amounts. And third, in the dark conditions, there was no visible carbon dioxide production at all. We also found that temperature affects the sugar level. The higher the temperature, the lower the sugar content, dropping to an average 14% compared to 16% in the lower temperature groups. So, what does this all mean? Our results show that higher temperatures speed up microbial activity, which accelerates fermentation, producing more carbon dioxide. On the other hand, at lower temperatures or in dark conditions, microbial activity slows down, leading to little or no carbon dioxide production at all. This supports the scientific principle that fermentation requires an optimal temperature for microorganisms to thrive and work efficiently. We would like to end our presentation on ginger soda here. Thank you all for your time, attention, and interest in our projects. We truly appreciate the opportunity to share our research with you. We hope you found it informative and insightful.